Good evening, class. I wanted to take the opportunity to go over question 9 on our second exam to kind of explain how I would approach solving this problem in the hopes that you might find that useful for your own how do we approach this kind of question. So what we're being asked here to do is write the student class to match the definition that is appearing in our UML. And this is actually taking a UML diagram, turning it into an active class. It's a very common task that you will find in a lot of programming jobs. So it is something you should be familiar with. It's something that we've been working with all semester. But this class may look just a little bit different potentially than what your classes look like, and you need to be able to interpret that diagram and figure out what to do with that. Now you may assume the appropriate using statements have been declared, and you can add any private or protected fields, methods, or properties you may need. And notice that we're already providing the namespace, but we haven't provided anything else. So the first thing we might want to do is go ahead and declare the class. So we're going to call this student, which is what it's called in the problem. And if we go look at the UML diagram, because that's where the rest of our information is going to be coming from, we can see here's our class, student, so the name matches up like we'd like it to. Go ahead and zoom in just a bit so we can get a tighter view on this. And we have 1, 2, 3, 4 properties: first name, last name, course results, GPA. We have a constructor, and then we have a private collection changed listener method. And notice we don't have a return on that, so we'd assume its return type is void. So we need to declare all of those things. We also want to look at the relationships between this and the other classes. Notice we have a dashed arrow going to the iNotify property changed interface, and we have a aggregation relationship between student and course result. So this is an is-a relationship, which usually means in C#, or it always means, that we're going to have a colon and something after it. So we're going to take this class and implement this interface. So we have iNotify property changed. And because we're implementing that interface, we have to have all of the things it declares in our class, which it declares that property changed event. And its type is property changed event handler, and its name is property changed. And because it's coming from an interface, we know it needs to be public, so we do public. And also we have the plus there showing that it's public. And finally we have the event stereotype. Now when we declare an event handler, it's very much like a field, but we add the keyword event as one of the modifiers. So this is what it should look like, and you should have done this on every class that you wrote that was a data class. So this should be very familiar to you. Now that fulfills the syntax requirements of this interface. However, the interface itself implies that we're going to actually invoke this event handler whenever one of the properties of our student class changes. So our first property in the class is public string first name. And we know it's a property, so we have to have a get, we have to have a set. And these are showing up here in the stereotype, and then we have the type here, and we have the name of that type. So this is what it would look like if we were using auto property syntax. But we can't use auto property syntax because we're supposed to implement the iNotify property changed. This is a property, when it's set, it will change. So we have to actually invoke the property changed whenever this setter gets called, which means the auto syntax is no longer an option. So we're going to have to declare a private backing field. And when we get our first name, we can just return that private backing field. And when we set, we want to set that private backing field. And right there we have essentially what the auto property is giving us, but we know we need a little bit more than that. We need to actually invoke that this property is changing. So in addition to setting the value, we're going to invoke that property changed. And our first argument is going to be the object that is the origination of this event. So this event is coming from our student class here. And the second argument is the property changed event args. We're going to pass in the name of the property that's changing. And we like to use the name of, and I'm going to drop down a line just so this remains in the video, first name. And we like to use that name of because that helps us avoid spelling errors. So then we go ahead and close this off. This could all be on one line. I'm just trying to make it fit in the video. And there are a couple different ways we could do, like the getter. We could use lambda syntax and just point it to the first name. That would also work. So that's our first name. We'd have to do the same thing with the last name. So we'll go ahead and add that. Then we have our course results, which is an observable collection that is also a property, so we need to declare that. Public observable and this one, because we don't have a setter, we could potentially use auto property syntax. But if we use the auto property syntax, we need to initialize it. And we can do that with a new observable collection constructor. And that would make sure it's initialized. We can also use the new keyword with just parentheses. This was some syntactic sugar that was introduced in C# 8 or 9, I don't remember which, but it basically means exactly the same thing. And the reason we can use new like that is we already know the type. It can be inferred by the compiler from the declaration here. So when we say new like this, we're saying new whatever was declared. Just go ahead and construct it. So that's not that different. And we have our GPA. Which we have to calculate. I saw a lot of students try to do this. That is an auto property. At this point, this GPA value is going to be 0, and it's always going to be 0 because we haven't initialized it to anything. Just like if we didn't initialize this, the value of the observable collection would be null, and it will always be null because we don't have any way of setting that value. There's no set in here, and there's no init. So the only way we can set this value is to have a value constructed and passed in as a default value. Now here, this will give us 0 as the GPA. That's obviously not what your students are going to want to get when they ask for their GPA. So you have to provide the calculation to get that GPA. What does that calculation look like? We had that up on the board in class if you remember. But basically what we do is we need to create a numerator and a denominator. For our equation, and we're going to do a for each. We want to look at all the courses in this observable collection of course results. Oh, and this actually needs a name, which we called it course results. So I'm slightly off screen there. We'll stretch this just a bit. There we go. Now this is a collection of course results. So if we iterate over it, what we're iterating over is course results. I saw some people trying to use grade or something else. The only thing we can iterate over directly here is course results, so we have to work with that. So our numerator we can actually set to be the sum of the grade, so cr.grade plus cr.hours. So the grade times the hours, that's the number of points this is worth. So the total points in our GPA calculation, grade point average. And then we also need to have the total number of hours a student has taken, which is our denominator here, and that's just the hours. So we add in the hours for this course to the denominator, the hours times the grade for the numerator. And we can get away with this because if we look at the grade enumeration, notice that an A is set to be a value of 4, a B is set to be a value of 3, a C is set to be a value of 2, a D is set to be a value of 1, and F is set to be a value of 0. Technically, we should probably also cast that just to say that I know this is an enumeration, but use the numeric value it represents, and that will actually work for us. You could also cast it to be an int because at this point it is an int, and if we add it to another int and save it in a float, it will be casted to a float. So this will work either way. Finally, when we get done going through each course, we want to return that numerator divided by the denominator. Other things you could call this, instead of a numerator, you could call this the points, because that's what it is, the points in the grade point average, and you could call this the total hours or the hours, and just do it that way. Be careful of naming these. You want to name them something that actually reflects what they're being used for. You don't want to name them something misleading, like call one of these average, because neither one of these is an average. This is the average when you actually do the calculation. So be aware of that. But we have to have this calculation in place. Now we also need our constructor. Public student. And there were a number of you that asked in your annotations, why do we need a constructor? Well, A, we need a constructor because it's declared here in the UML. But if you're wondering, why do I need a constructor here? That's a good sign that maybe you need to think about why would it be in the UML? What about it? What about this class would require a constructor? Well, setting the first name or last name to a value would be a possibility. Like we might say we want the first name and last name to start as an empty string. That's fine. We could do that down here because they do have a setter. You might think, well, we need to declare the observable collection, so maybe we do that down there. While you can do that, we can't do it if we only have a get. So if I was to actually say in here course results equals new observable collection, this is technically a syntax error because this is get only. There's no set. So we'd have to add a set, and because this doesn't have a set in our UML, we'd want to make it a private set, so only can be set from within this class. So you could have done that, but if we'd seen that, we would have expected a negative minus sign in front of our setter to kind of say that was the intent. So this is probably not why we wanted to do it either. And as a hint, we might look at this next method, which is collection changed listener. So we're going to do an event listener, public void collection changed listener, object sender, and notify collection changed args. So when this is run, what is this one for? Why do we need a collection changed listener? We don't implement the notify collection changed interface, and this is listening to a collection. The course results is an observable collection. It implements this collection changed listener interface, so we could potentially attach to its collection changed event, and the right place to do that is in the constructor. So we'd say course results dot collection changed and attach this listener. This is really the only thing that makes sense because the course results is the only thing about this entire project that implements notify collection changed, the notify collection changed event. So that's what we would expect it to be. So the question is, why do we need to have this event listener? Probably it's not supposed to be empty, so what would make sense here? Well, this event listener gets called if we add something to the collection or remove something from the collection. So what we're adding and removing is a course result from this collection. That course result is used to calculate our GPA. Therefore, what we're expecting this to actually do is change our GPA when we add something. Therefore, we probably should invoke the property changed for that GPA property. And this needs to go in a new property. Now, I also had students say the course results is changing. That's not technically correct because the course results property is pointing at what's constructed here. So it's always going to be the same course results because we can't change it again. We can't set it. So that property is technically the same object and not being changed. So it doesn't actually change. Its own properties are changing. Now, if you did that, I didn't count off for that, but it's not really what we're after. What we're after is this GPA changing, because that is a property of this class. Alright, so now we understand why we have a constructor, we understand why we have this collection changed listener, we understand how to calculate our GPA, and we understand that we need to create that observable collection. Now, I did see some students do this syntax and then go ahead and declare the observable collection and so on. This will not do what we want it to do. What this means is that every time we call the course results, we are constructing a brand new observable collection. That means we're throwing away the old observable collection and we're starting with this new one. So if we call this observable collection, add a new course result to it, and then a minute later call it again in order to add another course, the first course goes away, which means our GPA is not going to be calculated with all the courses a student has taken. So this is incorrect. You want to use this syntax, and the reason we want to use that auto property syntax is that means that when we construct this, we're constructing it once and we're always returning that one object that was constructed. You could have also added a private backing field. You still have to construct it here, but then you can use the lambda syntax to return that results. And this will be fine because what you're doing is just returning this, which is only constructed once. You could have also constructed results here in the constructor. That's another valid way of doing it. So a couple different ways you could have wrote this class, but the important things are you're always invoking property changed whenever a property is changing. So when the first name is set or the last name is set, you invoke for those. Or when we add or remove something to the collection, which the collection changed listener lets us know, we need to notify the GPA is changing because that's what makes the GPA change. Now, one final note, and this isn't something I counted off for, but a keen observer could pick out that if we look at this numerator and denominator and we have no courses results in our course results yet, when we get down to here, we have a division by zero operation happening, which could be a problem. I did see some students, so we could put a try-catch around that or do something to disallow dividing by zero and be careful about that. The other thing is you might recognize that this gets called every single time we call the GPA, we do this calculation. The GPA doesn't actually change when every time. It will often calculate exactly the same value until we add a new course. So a little optimization you could do is have a private backing field for your GPA. Set that equal to 0 or 4 or something or not a number, and then instead of making your public float GPA run this method, we could instead just return our underscore GPA and then create a private helper method. and we could either return the value from this or just set it directly in this helper method. I'm going to just set it in this helper method. So if we're doing this approach, we just set that private backing field. And then the question is, when do we need to call this helper method? Well, the only time our GPA changes is when we add or remove a course. So at that point, we would call calculate. Now the benefit to this is we start with a 0 GPA, or whatever default value we start with, because honestly, if you haven't taken any courses, your GPA doesn't really have meaning. Some people say it's a 4.0 at that point, some people say it's a 0. I'd say it's undeterminate. It doesn't really matter until you've taken a course. So as soon as we take a course, we then recalculate our GPA with the new course value, result values. That calculate GPA sets our private backing field. At that point, we'll be returning the updated value. We add another course. That's when we're going to recalculate GPA. This is called caching. This is a caching pattern. We're basically holding on to the value until we do something that should change the value. That means that we only do this calculation when we add a course, when we remove a course from our course results. It's a little bit more efficient. I wasn't looking for this on the exam, but I thought the opportunity to talk a little bit about other ways we could have possibly set this up. It makes a certain amount of sense to see some of those other patterns. So hopefully that clears up any questions you have about question 9 about how to implement that correctly.